So I didn't know he came up with that, but it is a well-known means of calculating the rate of temperature change in physics class.
Okay.
Yeah. So the way you do it is you have two materials at different temperatures.
All right.
Okay. And you bring them in contact in some way, either physically, so that atoms are touching each other, or have air molecules bouncing back and forth, or they're radiatively connected. You connect them in some way.
Okay.
Okay. And then you measure the rate at which the temperature changes so that they reach equilibrium to each other.
Cool.
Okay?
Right.
So it's not just that sorry. One of them might have a continual source of energy going in.
Mm-hmm.
So then the cool thing comes up to its temperature. You see what I'm saying? But if they're two isolated objects at different temperatures, they will meet in the middle somewhere.
Right.
At a temperature lower than the high one and higher than the low one.
Gotcha.
All right. So you can calculate the rate at which the temperature changes.
Oh, okay.
Okay? And deduce, as Isaac Newton apparently did. I own everything that man's ever written, and I got to dig that up.
You got to go dig up the law of cooling.
That must be a chapter I missed.
Yeah.
Okay? So what it states is the bigger the temperature difference, the faster the rate of change of temperature will be.
Okay.
Which kind of makes sense. It just kind of makes sense.
Yeah, absolutely.
Yes.
Right.
And if you do some measurements of that, you can actually represent it with an equation.
Okay.
And you make a prediction.
Right.
This is the temperature difference. They'll be the same temperature in 10 minutes.
Right.
Or, by the way, this is happening every day. You get a glass of water, you put ice in it.
Right.
Eventually,
it's going to be water.
The ice will melt. And then you have water that's cold, but it's still air temperature out here.
That's right.
Eventually that comes up.
And that comes up. That was an assignment in physics class when I was in 8th grade. And what we had to do was plot the melting of the ice in a graph to see whether or not it was linear. And it was.
Yeah, that would be a cooling curve.
Yeah, that's a cooling curve.
It's gaining heat from the outside.
Exactly. Yeah.
So
there you go. Look at that. See, people, these are the things you can think of when you are not busy thinking about sex, like Isaac Newton. This is what happens. You become a genius because you're just like, well, I ain't having sex, so I might as well think about how do things melt.
Yeah, he never married, had no children, had no known intimate relationships. And so we're pretty sure when he came up with his law of gravitation and motion and calculus,
right,
that he was a virgin.
Right. There you go, babe. That's it.